Welcome to Scaling React.js Applications, everybody. Let me do a quick survey before I start, because I don't know what the audience is made out of. Who in here has heard of React? Raise your hand. Well, it's almost the entire audience, more or less. Who in here has used React? That's, again, a big part of the audience. Holy cow. OK, what am I even here for? Who has used Redux? Raise your hand. That's like half the audience? OK, that's good to know. Anyhow, I'm Max. I work as an open source developer at ThinkMill. ThinkMill is an Australian agency. I'm not from Australia. I'm from Austria. That's not the same country. All right, just to make sure. I maintain Keystone.js, which is a Node.js content management system, and ElementalUI, which is a React.js UI library. Apart from that, I'm also the creator of React Boilerplate, one of the most popular starter kits for React. And we very recently released version 3 of React Boilerplate. And we put in a lot of work, and we talked to hundreds of developers, tried to figure out how they build their React.js applications, how they make it work for really, really big scale. And I want to share what we learned, basically. This talk consists of 4 sections. We're first going to cover what is scalability. What does that even mean? Second one is state management. Every big application will have state. Then architecture. And then we also need performance, because that's really important when you're building a big application. So what is scalability? What does that word even mean? When you go to Wikipedia, and I'm going to quote this because I don't know it by heart. If you go to Wikipedia, they tell you, scalability is the capability of a system to be enlarged in order to accommodate a growing amount of work. That was a very long sentence, and everybody's sleeping now. I have no idea what it means either. Basically, right, scalability was mostly relevant for backend systems previously. Well, you had, you built a product or a startup or something, and you had a database somewhere, and if you chose the wrong database or set it up the wrong way, you would run out of space. And then you put in more hard drives, more physical hard drives into your server. And then you'd, again, run out of space. And what do? You need a second server. And if your database wasn't set up from the start to be able to do that, well, you had kind of a problem. And your users were kind of like, damn, nothing's working anymore. Why can't I log in? Why can't I post a new post? Why can't I do things? And like, we have a database and it's full. Oh my God, what do we do? And that's exactly the same thing for the front end, except we don't have databases. We have application parts. And not only that, we also need to support more users, more developers, right? So the 3 big things we need to account for is that our application is going to be used by tons of users, tons of developers are going to work on it, and it's really big and has many components, right? Those 3 parts make up scalability on the front end. State management. When Facebook open sourced React, they also open sourced Flux, a unidirectional data flow library. Now, previously with Angular and Backbone and those sort of systems, what you had was something in your component tree very far down changed, right? And then that component would go somewhere and tell its parent, hey, something has changed here, you might want to change something. But then it could also go to another component and say, hey, I've changed. And then, suddenly these all talk to each other. And you end up with this mess of updates that you can't really follow. And you're like, whoa, what's going on here? Why did something over there change, even though something down there actually changed? Why is the bug over there? Why not? Oh my God, what's happening? So what Facebook gave us was this unidirectional data flow library. That, on a very basic level, means that when something changes down there, we go to a separate entity called a store. And that store, as the name suggests, stores our state. And then when something changes, updates the state accordingly. And then it goes to our top-level component and tells it to re-render. And then that re-renders, and it tells all of its children to re-render, and those then re-render and tell their children to re-render, right? And the nice thing is, we have this sort of cycle going on. Something changes somewhere in our component tree, we go to the state, we go to the store, the state just changed, we go to the top-level component, it renders down the entire tree. Something changes again, we go to the store, and so on and so forth. It's like this cycle of updates. And the nice thing is, it's really easy to follow as a developer what's happening, right? I know, OK, something down there changed, so we went to the store, that state now looks like this, so it goes to the top-level component, and that re-renders, oh, that's why there's a bug, because there's that data down there that shouldn't be down there or something. And it's really, really nice to work with. Flux had a problem. It was based on events, and it was based on a concept of having multiple stores for different parts of your application. And while that works all right, it wasn't perfect. You still had bugs that you didn't want. You had events dispatched that got picked up somewhere else. It was really confusing. So last year's React Europe, Dan Abramov released Redux, which is based on the same concepts, but adheres to functional principles. So you get pure functions everywhere. Everything is really nicely testable. You can literally go in and test every single part of your logic really, really easily. It's beautiful. It's really nice to work with. State management, all right? Keep that in mind. Redux is awesome. Architecture. And we're going to come back to Redux later. Architecture. The first big thing you want to do in your architecture is split your components in containers and components. Containers handle state or some sort of data, and they sort of work with it a bit, and then they pass it further down. They're connected to the state. Components solely care about the styling. A component might be something like a button, really easy component. Like it doesn't care about anything except that it's green if it's primary and blue if it's secondary or something, right? It's just concerned with styling. Containers, on the other hand, might be something like, post list or something, which has a list of posts and it handles all the data, but it doesn't actually have any styling associated with it. It passes those down to a post component further down the line, and that's then only concerned with styling. What that gives us is we have this sort of component tree, and you have intermediary levels of data management, right? So you have like a big sort of top-level component that might handle some state or might not, and that then gets passed down. And then somewhere in the middle, you can suddenly connect to the state again. And you're like, oh man, passing all of that down is too hard. We'll just connect to the state again. And then you can handle some data, you can manipulate it, and you can pass it down further. What you get is this clarity, because all right, I'm integrating with a different API now. The backend developers have changed something again. I need to update the way the data works, blah, 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 blah. I know I only need to look at my containers. If I pass down the data in the same way, if I pass down the same data, no matter how the API changes, we don't care. The components look exactly the same, right? And on the other hand, when you're changing styling, you're going to the components and you change the styling and you swap stuff around, and as long as you're still using the same data, your containers just do the exact same thing. You don't even have to worry about if that just broke your logic or something. No, it didn't, because you only changed that one component. Basically, a good summary would probably be containers are concerned with how things work, whereas components are concerned with how things look. That's the big difference, basically. The second big thing is structure. Traditionally, React.js applications have been grouped by type, right? You take the files and you group them by type, something like this. I had an example of a navigation bar. I hope the people in the back can read it. Otherwise, you just turn around and look at the back. You have like an actions folder, you have a constants folder, you have a containers folder, you have a reduces folder, and a CSS folder. And it's sort of like, you have some navbar, it has some sort of action associated with it that's open or closed, and you want to open or close it. And really, the problem here is when you want to work on this navigation bar, you have to add a new feature. You dig through half a dozen of folders trying to find exactly the one file you're looking for, and then the second file you're looking for, and then a third file, and it's just a pain to work with. So why don't we just put all of the related files in the same folder? Why don't we just group our files by feature instead, right? We could just do this. We could have a navbar folder and just put all the actions associated within the same folder, the component itself, the reducer, and the constants. It's all just in the exact same folder. How does that help with this? Now, we had a huge discussion on the React boilerplate repo, like 250 comments, I think, about how we're going to structure our applications. And somebody came in and said, hey, try this. It's pretty awesome. I was like, that sounds like the worst idea I've ever heard. Oh my God, that doesn't make any sense at all. Like, it's worked fine the way we've been doing it. Why would we change it? But I still tried it because I said, OK, no, might as well try it. And within 15 minutes, I was like, OK, I am never building an application differently again. It's just so nice to work with. The first big benefit is easy renaming and moving, right? Imagine you want to add a secondary navbar because your application has grown. So you want to rename your navbar component to primary nav. If you have 5 different files with imports and stuff, you have to be a regex magician to make that work across a big code base and change all the imports really, really well. Whereas when you have one folder, right, this is what an import looks like. Import toggle nav from containers/navbar/actions. And you can just do a global find and replace for /navbar/ and replace it with /primary nav/, and suddenly it just works. And then you rename a single folder, and everything works again. Like, it's not harder than that. Really, how often do you rename things, though? Like, that doesn't happen very often, does it? It's a really small benefit. The really big benefit is we can work from a single folder. As a developer, I can go in. I need to add a feature to my navbar. I go into that one folder and make it happen. I don't need to search in freaking thousands of folders, thousands of files. I just go into that one single folder and work in it, and then push it up and go, hey, I've changed something. And then another developer could have changed something somewhere entirely else, and it wouldn't concern me at all, because we're not even working in the same folder. There will never be conflicts. It also gives us these nicely reusable components, right? You could just take that folder, make an NPM module out of it, and push it up to a private registry. When you have multiple applications, you can simply reusing it by npm install, and then you've got all the logic associated with it in one simple package. Then you just import it, and it just works. Now, that's quite nice, right? But when I tried it, I was like, well, what are we going to do with styling? CSS is really nice. But in a component-based architecture, it has two big problems: global names and inheritance. So with names, I mean, everybody's had this problem probably before. If you've ever written CSS, that has happened to you. You can get conflicts. You have two different CSS files. In one you say .header and .title, and in the other you say .footer and .title, and suddenly you get a conflict. And your title on the entire page has a yellow background and a blue border. Now, if you make your title have a yellow background and a blue border, I think you're doing something wrong. This is just an example, right? But you can see where I'm getting. The global names can conflict, and they shouldn't, really. Our component should look the same no matter where it is. Some people from halfway around the world, Australia, have come up with a really smart solution called CSS Modules. It works like this, right? We import our styles into our component, and then we assign a class name of styles.footer. Now, this styles.footer gets passed out of our CSS file by CSS modules. So in our CSS file, we still just write .footer and .title, and that's it. And CSS modules goes in and uniqueifies these class names, right? It prepends the app name, and it postpends a hash of the contents of the class. What that means is, even if there's another .title defined somewhere in my application, I don't care. Because there's a hash postpended of the contents, these class names will only overlap if the contents are exactly the same. And if they aren't, they're two completely unique class names. So we completely avoid naming collisions. Now, that sadly doesn't get rid of all of our problems, because we still have inheritance, right? And when you have a component, you want that component to look exactly the same, no matter where you put it. You don't want it to suddenly inherit some sort of line height, and your button suddenly doesn't look the way it should anymore. You want that button to look exactly the way it should. You just want it to be a button. That's it. Again, we have the same problem, right? In our header, we have a line height of 1.5 em, and in our footer, a line height of 1 em. And suddenly that inherits down, and our component looks differently. In CSS, there's this concept of a reset, right? Everybody in here has probably heard of reset.css or normalize.css or sanitize.css. There's tons of them. They aim to sort of reset the styling, make it the same across all browsers, so you can then build your own styling on top of that. What if we had a reset around every component? What if we just said, all right, we don't care about the inheriting properties. Just set them to the default value, and then nothing can inherit anymore. That exists, and it's called an auto-reset. PostCSS is an awesome CSS preprocessor. I highly encourage you to check it out. But the point here is that it has a plugin called PostCSS Auto Reset that does exactly that. To every single component, it goes line height, default, and it sets all of the inheritable properties to the default values. And that way, nothing inherits anymore. We completely avoid any inheritance issue. Now, you might still want to have inheritance, and you can still say line height inherit for your component if you want that component to look differently. But it's inheritance no inheritance by default, and then inheritance by effort, which means we avoid a ton of bugs that we would have otherwise had. And since we're doing that, why not just put this styles file in the same folder? We don't need to have a global CSS folder. We can still have a variables file, but put the styles related to a container. That's a pretty bad example because a container shouldn't have styling, right? But bear with me. Put the styles that care about a component right next to the component. And now when you push that up to an npm registry, you've got everything you need. You can literally type npm install company/navbar, and you've got your navbar. It's going to look the same across all of your applications, no matter what happens. We've achieved component isolation. But there is one problem. Because at the moment in the Redux world, people like to fetch data, right? Everybody needs to fetch data from somewhere. And that's mostly done using funcs, where you return a function from your action. And your actions are responsible for the data fetching. Now, that means we still have global actions. Where do we put these now? How do we solve this? Before we take a look at the data fetching, I want to give you a short example of two components, right? You have a clock component, and when you press start on the clock component, a timer component should start, right? It starts ticking, 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 ticking. And when you press stop on the timer component, that then shows the time on the clock. And traditionally, people do things like this, right? The clock has an on-start click prop, and you dispatch a start timer action from there. And then from the timer, when you click the stop button, we dispatch show time there. And those actions are specific to these components. But now, really, we've taken our really decoupled components and really tightly coupled them together again. Like that clock won't work without the timer, and the timer won't work without the clock. That's not very ideal, is it? Now we have all of those files, but now they're tightly coupled again. Ugh. Yassine El-Ouafi recently released this thing called redux-saga. Right? Redux-saga uses ES7 generators to give you really nice, simple asynchronous flows, and that lets you couple together your really decoupled components again. And it can also be used for data fetching, and it's easily testable and beautiful. Now, let's change this example slightly, right? Instead of coupling them tightly together, we just dispatch a start clicked action from the clock and a stop clicked action from the timer. And then we use a saga to tie them back together. Now, this is ES next syntax. It's not finalized yet when it will be in the spec. But if there's a function keyword with an asterisk afterwards, that's a generator. And it says while true, right? That's an endless loop. Whoa, endless loops. Oh my God, that's not a very good thing, is it? But generators are functions that execute until they reach the yield keyword, right? And we have a yield keyword here. So what happens now is that the generator stops executing. This function doesn't execute anymore, and then waits for the thing on the right side of the yield keyword to take place. That could be data fetching. That could be, in our case, we're waiting for an action to happen, right? In our case, we're starting the generator and then stopping it again to wait for the start button clicked action from the timer, from the clock, sorry. And then when that happens, that's when the generator goes on and executes further, right? The function doesn't run until this happens. So then when that happens, we just dispatch a start timer action, and then we wait again. Generator stops executing. Now, my mental model for this is sort of like a separate thread in our application, right? It's sort of like you have this thing that does asynchronous stuff somewhere, right? And it does some sort of like, it waits for things to happen. It does this sort of thing. But it's kind of like not in our main application. It's like a separate thing. Now, in our example, we're waiting for the stop button clicked action. And when that comes in, we simply dispatch a stop timer action and a show time on clock action. This is also why we have here while true, an infinite loop here. Because if we didn't have that, the generator would stop executing now. And the next time somebody clicks on the start button, it won't work. So by having a while true, we just go back to the top. But we don't execute anything because we have a yield keyword, right? So we just wait until the next action comes in. This allows us to have really, really decoupled components and then tie them back together with sagas. Short summary of this section. Split your components into containers and components. Group your files by feature, not by type. Isolate the styling of your components with CSS modules and some sort of auto-reset. And use redux-saga to tie those decoupled components back together and get really nicely looking, beautiful asynchronous flows. Let's talk about performance. We had a great talk by Ben in the morning, who said that performance is really an important metric, both load time performance and application, actually like the application runs performance. Let's talk about load time performance. I use Webpack as my bundle of choice, but this also works with JSPM, and I think it works with Browserify, but I'm not 100% sure. But Webpack gives us code splitting. Now, currently in the React.js world and with like JavaScript frameworks, what people sometimes do is they just take all of the files you have, put them into one massive bundle, like 10 megabytes or something, and then just push that down a user's line and have them wait for like 10 minutes for your application. But that doesn't make any sense, does it? Right? If you have a web server and you just upload static HTML files, what happens is you go to a page and you download only what you need and some common stuff, right? So you only download like the content for the home page, but not for the about page, not for the main application, not for some sort of form or something, right? Just the home page. And then when you go to the next page, the browser has cached the common things, and then you only download the content for the other page. That's what Webpack code splitting does. It intelligently determines, right, where it needs to split the bundles, where it needs to put different files into like a common file that every bundle will need, or like a bundle over there for the about page, and a bundle over there for the home page, a bundle down there for the application. And when a user visits your page, it doesn't get the entire big application with potentially hundreds of components. It won't make any sense, right? Only gets exactly what he needs, and that's it. And then when he goes to the next page, Webpack automatically ajaxes in the content that we need for this bundle. It's super easy, super beautiful, and works really well. The problem is they're currently in the middle of building version 2, and the syntax has entirely changed. I would love to show you code, but it's not finalized yet, and I didn't want to show something that was going to change in like 2 weeks, you know? So look it up, Webpack code splitting, there's a beautiful doc explaining how it works. Let's get to runtime performance, right? We might have a potentially really, really big component tree. And then again, somewhere very far down in our component tree, something changes. An input gets changed, for example. And we go over the store to the top level component, and then tell the store to change the state, and then that goes to the top level component and tells it to re-render. And then what happens is that re-renders, and then it re-renders its children, and then those re-render their children, and so on and so forth, until finally we've re-rendered the entire application. The problem is we didn't want to re-render the entire application. We just wanted to re-render that part. We don't care about the rest of the application changing. We just want to like just that one path. Now, if you heard Pascal talk about Angular 2 yesterday, React has a very similar concept to their on push. We call it should component update. Now, should component update is a lifecycle function of your component. And when you return false from it, the component doesn't re-render. When you return true from it, it does re-render. Now, we can bail out of updates, right, by returning false. So in this case, we really want to bail out at these 3 places, right? And the most important one is the one at the very far right, right? Like we want to bail out as high up in our state tree as we can. We want to bail out that far up. So none of the components further down even need to care that something changed. This will really be the biggest performance impact. The one down there is like, okay, one component re-rendering or not, doesn't really matter. But the entire half of the application not re-rendering, that's huge. Now, what we want to do basically is we get past this next props variable that just has the next props. And we really want to return next props does not equal this.props. Then JavaScript gets in our way. In JavaScript, when you have 2 objects with the same contents, they aren't necessarily the same. It's reference-based equality. And so what we would kind of have to do is we would have to go in our really like high up big state trees into our high up components and deeply compare 2 potentially massive state trees, right, with hundreds of properties and values, and we'd have to loop over every single property, nested object, nested arrays, everything. We'd have to loop over every single one and compare it to the other one and see if it's the same or not. And then if it isn't, re-render. The problem is if we do that in every single component, right, that's really expensive. Like deeply comparing object isn't something that you can do really cheaply. It's really, really expensive. As Pascal said, there's a solution to this, and that's immutable data structures. Immutable.js is a library that gives us immutable data structures in JavaScript. And they have this from.js function. You pass in some sort of object that can be nested, self-referencing, doesn't matter, they take care of it. And then what they do is they give you this variable that you can't change anymore. Like in this variable called state, if you even try to change something, they throw an error. And you can use state.set and pass some sort of property and value, but that's not going to change that specific object. It's going to create a wholly new one, because the state is now immutable. It can't be changed anymore. That allows Immutable.js to go in, and when you create your state, what they can do is generate a hash based on the contents of the object. So they can go and save like a, 10-character string in a private field, and then you can go with 2 objects that have the same content, you can go to equals. And the only thing they have to do is compare 2 strings. And it's deeply equalized, right? We deeply check that they're exactly the same, really, really, really cheaply. With Immutable.js, deeply comparing objects is really, really cheap, which allows us to bail out really, really high up in our component tree without any sort of performance impact. So again, something has changed somewhere very far down. We go to our top-level component, and that starts re-rendering. And it re-renders its children, but we bail out. So suddenly, only the one path we wanted to re-render has actually changed, right? Just that path we wanted to change. All right, short summary. What is scalability? Our application needs to handle more users, more developers, and more components, basically. State management. Use a unidirectional data flow library. Redux is awesome. Architecture. 4 points here. Use containers and components. If I would remember them, that is. Use containers and components. Isolate your styling. Group your files by feature, not by type. And use redux-saga to tie your now really decoupled components back together. And then performance. Code split your application with Webpack or JSPM. And use Immutable.js to get really cheap, deep comparisons of your state. Thank you very much.